Hello, everyone. This is the second class of TLS. So in this class, let me briefly recap what you have learned so far. And also, we're going to focus on today's topic, which is revocation. So TLS is a transport layer security, which is preceded as SSL, which was originally proposed. It was the Netscape. Yeah. So TLS, TLS also uses a public key infrastructures. So using a public key infrastructure, it uses a certificate which binds a public key to a domain name, and to support confidentiality and integrity and authentication. So this was a quick example how you can verify the certificate. So website now to support TLS, HTTPS, it has to have a public-private key pairs, which is vouched by the CA, Certificate Authority, so that the CAs, after vetting process, CAs issues a certificate, which binds a public key to a domain name. So once a browser gets this certificate, it has to check whether this certificate is valid by checking whether it is correctly signed by CA's public key, and also the CA's signature can be verified using a root certificate's public key, which is in your root store. So this was the same concept that we have learned so far in DNSSEC and the intro of this class, which is PKI. So each browser these days, browsers have their own root certificate, and also OS as well. So OS has a set of root certificates, and again, you can find public key information in the certificate so that you don't need to trust all the massive number of certificates. You just need to only focus on a small set of certificates public key, which is called root store. Yeah? So when you go to a website, and of course, the website, if they support TLS, they will give you a certificate, which includes a public key. But most of the time, the certificate does not in your root store, right? So what you can do is you have to check whether this certificate is ultimately signed by one of your root certificate. Okay, so it is called chain of trust, and if the chain of trust is valid, then you can trust the certificate. Okay? So last class, I showed you the certificate structure and what kinds of information in the certificate and the process of the acquiring certificate. So let me skip that. And now let's move on to today's topic, which is the revocation. Sometimes the certificates can be revoked, right? So revocation means even if the certificate looks valid, what I meant by looks valid is it has a correct signature, it has ultimately signed by one of your root certificate, and it has not expired yet. So by only looking at this certificate and do all the validation process, the certificate is valid. Okay. But the thing is, the certificate can be revoked. Okay. So excuse me. In some cases, certificate can be revoked. For example, let's say the CAs got compromised, and the hackers successfully got into a CA system, so that the hackers were successfully issued a certificate for a domain name such as google.com, which was never initiated by Google. Right? In that case, the certificate would be looking valid, right? But the truth is, the certificate should be treated as kind of invalid certificate because the certificate was issued by attackers, not a legitimate owner of the domain name. Okay? So we can protect the client from accepting misissued certificates by using revocation. So In that case, let's say in this example, the attacker successfully compromised the website system, so that it can successfully store the private key information. So as soon as the certificate owner, the website owner, notice this attack has happened, it has to go to its CAs and ask them to revoke the certificate. Yeah? So that the browsers can, if the browser can get the certificate, they can check whether the certificate has been revoked or not. And if it is revoked, then the certificate has to be rejected by the client. Yeah. Then the client, the browser, has to have some mechanism to fetch this revocation information. Okay, so typically there are two methods to collect this revocation information. The first one is pool-based mechanism, which is CRL, Certificate Revocation List, so that the browsers, whenever it gets the certificate, it can fetch the URL of the CRL and fetches the list. And then after that, the browser checks whether the serial number is in the CRL or not. Yeah. So if the serial number is in that revocation list, it means the certificate has been revoked, so that the browsers can reject the certificate. Another one is called Online Certificate Status Protocol. So browsers, once it gets the certificate, it parses the URL, which points out the certificate authority database, and it sends the queries to the CA's database with the serial numbers to check if the certificate has been revoked or not. Then the CA's repository will give you the answer whether it is good or it is revoked or unknown. And if the client gets the response of the CA's responder saying, hey, the certificate has been revoked, then the browser has to reject the certificate. Okay. So let me walk you through, let me focus on the CRL first. Okay. So CRL, basically a list of revoked certificates. So browsers has to download this CRL information. And after that, it checks the kind of membership check. Okay? If the serial number of the certificate is in the CRL, it means the certificate has been revoked. Okay, but as you can imagine, you don't need to actually check all the list of revoked certificate, because what you are ultimately interested in is just a single certificate's revocation status. Okay. One research found that about 5 or 6 years ago, it found that some CRL, this size is really, really big. It can be up to 76 megabytes. So what it meant by is you went to a website, right? And you got the certificate. And after that, you have to parse the certificate to extract the CRL, URL information. And after that, you have to fetch this CRL. And after that, you have to check whether the certificate serial number is in that CRL or not. Okay. So until this point, you haven't fetched any website information yet, right? The content has come yet, because you have to finish. You have to make sure the certificate has not been revoked to fetch the content from the website. Okay. So if the CRL size is too big, then you have to wait until downloading 76 megabytes of the information, which is really inefficient, right? So let me give you one example of how you can find the URL information of the CRL and how you can parse it using OpenSSL. So in this example, we're also going to use the SKKU website. Okay. So when you go to skku.edu, then you can find this padlock icon, which tells you the communication is secured using TLS. You click the certificate button, and this shows you all the details of the information of the certificate. Last class, I showed you how you can fetch this certificate information using OpenSSL, but let me just use this Chrome browser information. So when you scroll down to the bottom, you will see there is an extension field, and click the CRL distribution point. You can find this URL. Okay. So now what I'm going to do is, let me fetch the CRL. Let me download the certificate information. So I just download it, right? And after that, I'm going to parse the certificate CRL revocation list, right? So open SSL, and I'm going to parse CRL. And last class, I showed you that there are two formats, widely used format, which is PAM format, and the DER, the binary encoded format. So I'm telling the OpenSSL that, hey, the format you will parse is DER, and we are going to use a text off form and the NOAA, which means I'm not, you don't need to show me the original content of the CRL, so I'm going to skip it and info file. Okay. Then what you can see is there is a long list of the serial numbers, right? For example, hey, the serial number is like this one, and it was revoked in December 4th. Okay. Sometimes you can find the reason of the revocation, but because of this, for example, cessation of operation. But sometimes, as you can see, this revocation reason is almost empty. Okay, because maybe they don't, the CS that doesn't want to reveal such information, and so it is optional. But the serial number and the revocation date is mandatory. Okay. So internally, the browser, Chrome browser, actually Chrome does support CRL at this moment, OCSP as well. But if they supported, let's say back in the days, about a few years back, they supported CRL. So internally, what they did was they got the CRL. They first they fetch the certificate from the web server, skk.edu web server, and the browser parsed the certificate and extract the URL of the CRL and download it and check whether the certificate serial number is in the CRL or not. If it is not, it means the certificate has not been revoked, so that you can finish the transaction, TLS and the shake. Okay. So as you can imagine, so actually the reason why Chrome decided not to support CRL anymore is because of this issue, right? It is not efficient, okay? Because again, the people have to, it is always better for the clients to see the actual content from the website as soon as possible. But imagine that the CRL size is too big, right? And the client has to wait until the CRL check is done to get the content from the original, to get the content of the website you visited, right? If the CRL is too big, right, then you have to wait much longer, right? Much longer until to see the first content of the website, which makes really user experience of using browsers make it really worse, right? So CRL is considered as really inefficient. Okay. So to solve this challenge, Online Certificate Status Protocol and OCSP was proposed. Okay, the concept is really simple. So the CA now they maintain another web server called OCSP responders. Okay? And once the browser gets the certificate, it extracts two information: serial number and OCSP URL. This URL information is also in the certificate. So what the browser can do is it sends a HTTP request with typically using a post method, right? By attaching the serial number to these OCSP responders. Then because you are only interested in this certificate serial number, so that it is much more efficient than CRL, right? And the OCSP responder checks this database and returns either revoked or good or unknown information to the browser. So if the certificate status is revoked, then the browsers have to terminate the connection immediately. But if the revocation information is good, it means the certificate is ready to go, ready to be used, so the browser can finish the TLS handshake. Sometimes the CA responder or CSP responders may return unknown message, right? If the certificate, when the certificate is no longer is in the database. Maybe it is because certificate has been already revoked. I'm sorry, also already expired, or you might contacted the wrong CA server. So also, let me show you how you can actually test this OCSP protocol using OpenSSL command. So now, what you need to do is we first get the certificate information, right? So let me first use this command, which I showed you in the last class. Like what I did was I got the certificate change of skk.edu, and this is the lift certificate, and this is the CA certificate, right? So when you send the OCSP queries, you need to have two information. The first one is the serial number, and also the CA OCSP responders. I'm sorry, three information: OCSP solver URL, and also the CA certificate. Because, so let's say you might be wondering, hey, there could be a man-in-the-middle attackers who snatches this response and returns some wrong response to the browser. But actually, this OCSP response is signed by the same CA, right? What it meant by is OCSP responses carry a signature which can be verified the same CA's public key, right? So let's say SK. So remember that there are when you go to the website, the websites give you at least 2 or 3 certificates, right? Lift certificate, in this example, skk.edu certificate, and it is signed by some CA certificate, right? So the OCSP response carries a signature which can be also verified the same CA certificate. Of course, when you go to in the deep dive into the details, it is not always true. Sometimes OCSP response can be signed by another certificate, and that certificate information is also encoded in the OCSP response, and this certificate can be verified using the same CA certificate. But it is a kind of advanced model. So let me skip the model at this moment. So you need the CA certificate. Okay, so what I'm going to do is Word. So I just save this certificate, right? And after that, I'm going to parse, and also we need a serial number, right? So I open the browser, I got this serial number, right? And because the serial number is a hexadecimal format, so what I'm gonna do is, I'm using just the Python, okay? So what I'm gonna do is, all right, oops. I replace it, and also I'm going to change it to decimal format, all right? So we got these serial number, all right? So I told you we need a 3 information: CA certificate, serial number, and OCSP URL. So let's find out the OCSP URL. So when you scroll bottom, there's authority information access, and you can find OCSP responder URI, which is status.dorothy.com. Okay, so OpenSSL, I'm going to use it on issuer information was Dort the PAM, right? And the serial number was, I'm sorry, serial number was this long, right? And the URL is this one, okay? And sometimes the host, the web server may support the virtual hosting, which means the same IP address can host multiple domain names. So in that case, we have to specify the host information, okay? Okay, so what I did was I sent a OCSP request to this URL, right, to ask the certificate verification information of this matched serial number, right? So as you can tell, because I didn't verify the OCSP response, but let me skip it. But the actual information we need is this information, right? So as you can tell, the certificate was not revoked and the status is good, so that we can confirm that the certificate has not revoked yet, so that we can move on. Okay, so I just use a Chrome browser, but when you use a Firefox, internally Firefox supports OCSP. So whenever you use your Firefox, I believe there is another Firefox nightly version. They use another mechanism called CLite. But if you're using, I believe, I might be wrong, but if you're using just the plain Firefox, they still do support, they still check OCSP. So when you go to the website using Firefox, you get the certificate and parse the serial number and OCSP URL and sends the OCSP request to the CA's responder. And after getting the good response, good status is good from the CA's responder, and now then the client is safe to complete the handshake and get the content from the web server. All right. So, and as you can imagine, this was, let's say there are, the entire students in the same classroom try to visit the same website, right? That means one website has to serve the multiple verification information to OCSP responses to all the clients, right? So to make it more efficient, the OCSP responders can use a CDN, content delivery network, to make it cache this OCSP response, right? So that same response can be used for multiple clients OCSP check. Because of that, OCSP response can be cached, and it also carries a caching period. So it says this OCSP response can be cached between this update field and the next update field. Okay, so I just requested my CA OCSP response at December 11, but actually this response can be cached from December 10 and December 17. You might be wondering, hey, the attackers, let's say this website, skk.edu's website, got compromised on maybe December 13, right? Let's imagine, right? Then the attackers can capture this response and keep serving this response until December 17th. That attack scenario is totally possible. This is called OCSP replay attack, right? But as you can imagine, this is a trade-off between usability and attack vulnerability window, right? If you choose this vulnerability window, make it bigger, it is more efficient for OCSP responders to serve the cached response. So the efficiency is, efficiency is great. But on the other hand, if you make this vulnerability window is really big, let's say 1 year, it means the attackers can use the same response at least 1 year, right? So you have to choose, if the CAs have to choose the correct time, right? Correct caching time. So typically it is just a week. So let's move on. Now, let's talk about some challenges of this OCSP protocol. So there are actually many problems you can imagine. So the first one is the OSS response has to be coming from the third party, which is CA. Okay, so OSS responders need to provide such responses with high availability and low latency. For example, let's say you requested, let's say you a browser, okay? I refer you as the browser. Let's say you sent a OCS request to the CA, and let's say the CA servers got, experiencing some outage, so the response is not coming. Then what do you need to do, right? Are you going to assume it is valid, or are you going to assume it is revoked, right? So CA has to provide such responses with high availability and low latency. If the response, if it takes more than a couple of seconds to get a successful response, then it makes the user experience really, really bad, right? Even if you connected to your website really fast, like with very short latency, but imagine the response, OSS response comes after 5 seconds, right? Then it makes the user experience really, really bad, right? So that's the reason why a typical OSS response is served from the cache, but let me skip the topic at this moment. And another issue is privacy issue. Because whenever you go to the website, you have to send the serial number to the CA's repository, which means CA already knows the mapping information between of serial number and the website. So CA can basically track users' browsing behavior, right? So CA knows which website you're visiting, what websites you're visiting. So to solve this limitation, one extension to OSSP was proposed. It is called OSSP stapling. So as you can tell from its naming, the OSSP response is stapled to the OSS this certificate. You know what the stapler means, right? It is stapled, right, with the certificate. So let me show you how it works. The concept is really simple. So website, before a browser connects to the website should fetch OSSP response in advance from the CA's OSSP responders. So because the OSSP response can be cached, right, for a certain amount of time, let's say a week, the website can cache this response for a week, right, so that it can return this staple information to the browsers along with the certificate, right? So because the OSSP response is already served from the website, and again, OSSP response can carry OSSP response carries a signature, which the browser can verify the signature using the same CA certificate, which is also coming from the website. So the browser does not need to contact CA's responders anymore, right? So it does not cause any additional latency, which is really good. And the CA cannot track the browsing behavior anymore because the browser no longer sends any OSSP requests to the responders. But the still challenge remains, right? Which is called soft failure. So it is not only applied to the OSSP model, but it can be also applied to many security models. So soft failure is more like a general concept of how you handle the failure. Yeah. So let me give you an example. Let's say browser tries to fetch the certain OSSP response from the CA. Okay, and let's say the attacker stripped it out, right? So network attacker sits in the middle of between browser and the CA's responder, and imagine that the attacker successfully stripped, right? Blocked the OSSP response. Then what can the browser need to do, right? The browser should treat it as a revoke, right? Or just treat it as good. Or if the staple response comes from the from the website, the attackers can also strip out the stapled response, right? So that the attackers can always do denial of service, right, of OSSP response. Then in this situation, browser need to take an action, right? If the OSSP response is not coming, then browser has two choices, whether it treats as a kind of revoked, right? The certificate has been revoked, or certificate is just good. So most client, the reality is, most client will accept the certificate even if they are unable to obtain revocation information, right? So it assumes that the certificate is good, which is called self-failure. If the response is not coming and the browser regards it as a kind of revoked, right? Then it is called hard failure. But most of the browsers just uses self-failure. Let me tell you the reason. So let's say there are many cases where the browsers are in the very bad network condition, right? In that case, the browser may have some network issues, intermittent network issues, getting the OSSP response from the website or from the CAs, right? Then this issue is just located at the client side, right? It is nothing to do with certificate or CAs or website. It is just a problem of the browser, right? Browser network condition, right? So if you treat this network issues as a kind of revocation, it is really, it is not good, right? It is because it was nothing to do with the certificate itself, right? So because of this, this is the kind of main reason. So the browser just treated, if the response is not coming, then the browser always just treated, all right, there must be something in my network issues, right? So I will just treat it as a good certificate. So this is the kind of, this does not apply to OSSP, but also applies to many security protocols. So self-failure model always come with this challenge. So to solve this issue, another OSSP extension was proposed, which was called OSSP must staple. So as you can tell from its naming, must staple means it is telling the browser that you will receive a stapled OSSP response. So if the response is not coming, you can just treat it as a failure so that you can reject the certificate. Okay. So let me tell you how it works. It is really simple. So when the website gets a certificate from the CA can encode a special character in the certificate. It is called must staple extension, which carries a special OID, this number. Okay. It is a kind of explicit signal for the clients that, hey, if you fetch this certificate and if you find this most stable extension is on a certificate, and you will receive the OSSP stable response from the website. So it is like there is no special function in this OID. It's just to let the certificate, the clients that you will receive a stable response. So it is a kind of, so when the website got this certificate, then the website has to fetch OSSP response in advance, because the certificate has this extension. And the browser fetches this certificate, and if the browser finds this most stable extension is on, the browser expects this OSSP response will be coming, right? So let's say if there is an attacker in the middle, let's say it strips out the OSSP response, then the browsers can still tell that the certificate says the response will be coming, but it has not come yet, right? So the browser can be assured that I can reject this TLS addition. So it does not cause any additional private latency, and It does not have any latency and the privacy issue. And also it can nicely solve the solve failure issue. So, which looks really great, right? So, before moving on, let me just quickly recap what you have learned so far regarding replication protocol. So first, there are two ways to fetch replication information. The first one is CRL. So, that you can get the long list of serial numbers from the CA, and you can check whether the serial number of the certificate is in that CRL or not. But the problem was sometimes it is too big, right? So it is really inefficient. So the next protocol was designed called OCSP. The concept is really simple. You parse the certificate and you send a OCSP request via HTTP. Again, it doesn't need to be HTTPS, all right? HTTP, so that you can get the response. And the response is signed by the CA's private key, so that you can use the same public key information of the CA that signed this LIF certificate to verify the signature. So if the response is good, it means certificate has not been revoked yet, so that you can just finish your TLS and share. But there is many problems. There are many problems, such as the CA has to manage the solvers with the high availability and low latency, and moreover, the CA can track users' browsing behavior. So to solve this challenge, OCSP staple was introduced. The concept is the website fetches OCSP response in advance on behalf of the browser, so that the website can serve the certificate as well as the OCSP response to the client. But still, there are some challenges, such as soft failure. So the browser, when the response is not coming, so the browser has to take an action. But in reality, the client just assumes that the certificate is valid. So to solve this issue, must staple was proposed. The concept is very simple. It encodes a special command, special character in the certificate to let the browser reject TLS handshake if the staple response is not coming from the website. So, OCSP must staple looks really great, but the managing and the supporting this OCSP staple is not that straightforward, right? So because to support it, CA must have include to support must staple. It has to include a must staple extension into a certificate, and the client has to support this extension, which means if the client sees this special OID identifier in the certificate, it has to be able to understand what this extension is. And also, it has to reject the certificate if it is if the OCSP response didn't come from the website. In the web server, it has to fetch a response in advance and configure the web server software to use stable response. So let me quickly show you if the current PKI ecosystem is ready to support OCSP must staple. Yeah. So to support that, we can simply measure the OCSP responder. So there are, again, as I mentioned, there are three perspectives. The first one is the CA has to provide has to maintain their infrastructure with availability, good availability, and also low latency, and OCSP response has to be consistent with the CRL. So we can actually measure it. So for example, we can obtain all the certificates out there and over the internet by scanning IPv4 addresses and connect to their web server from the port port number 443, which is the HTTPS web server. So now after that, we can validate it and we can extract the unique 500 OCSP responders along with their 14,000 certificates. So what we're gonna do is we're gonna implement the measurement client, so which is basically sends OCSP requests to the CA's OCSP responders on a regular basis, so that we can install this machine bot basically in many AWS regions, so that we can collect all the OCSP responses. So this is the simple plot to show you how you can, it shows you the availability of OCSP responses, OCSP responders. X-axis shows the date and Y-axis is a percentage of successful requests. So in ideal situation, this has to be, the graph has to follow the 100%, right? Because the OCSP responders have to serve OCSP response every time correctly. But in reality, it's not. And as you can tell, it is not 100%. And also, it varies a lot depending on where you send OCSP requests. For example, when you send OCSP requests in São Paulo, sometimes you will never be able to receive some responses, right? As I said, there are some geographical differences. So for example, some OCSP responders used by Wells Fargo, which is one of the large banks in the United States, it returns all the false, it does not respond to the clients in São Paulo, in Brazil. And also sometimes the OCSP responders experience outage because it is, we don't know why they experience, but as you can tell, sometimes this web server experienced outage, and which means sometimes the clients will never be able to receive the response. So for example, Komodo servers experience a lot of outages during the measurement period. Yeah, so you can actually evaluate the impact of this CA's OCSP responders outage, because imagine there are many popular websites, and of course, the number of the CAs is far less than the number of the website, which means some websites must share the same CAs. So there, if one CA's got, experiencing, it was a CA's responder experiencing outage, it means the many popular website will not be able to returning the OCSP response to the client, because they also cannot get the OCSP response from the CAs or responders, right? So we can imagine how many popular Alexa 1 million websites were not able to receive OCSP response from the CA's OCSP response solvers because of this outage. So as you can tell, if one popular OCSP responders experience outage, the impact is huge, right? For example, tens of thousands of websites cannot support OCSP stable at the moment. Yeah. So the quick conclusion is these responders are not fully reliable. So now let's move on to the actual validity of the response. So which is we can parse. So the question here is whether the OCSP response we collected is parsable or not. Sometimes if the OCSP responder is misconfigured, the response may not be just the gibberish, right? So which means the client unable to parse that information. So during the measurement period, at least 2% of them were invalid, right? Which was not parsable, which was just the gibberish. So another perspective is consistency. So at least OCSP response and the certificate validation status obtained from the CRL have to be consistent. Because imagine if it is different, right? Let's say one says it is not revoked, let's say the other one is says it is revoked, then client will be confused. Depending on which protocol they choose, the response will be different. So the client will be puzzled, right? So what we can do is we can download all the CRL information and OSSP URL, and we collect all the CRL information called responses, right? And we can compare if they're consistent or not. And our finding is sometimes, of course, it is really small number, but sometimes their responses are not consistent each other, and we contact them, and it was because they are managing two different platforms with the two different databases. Sometimes it takes a while to synchronize one each other. Yeah. So we actually contacted one responder CAs, and he says, hey, we are managing two different platforms, and the CRL management is easier and simpler, but the OSSP gives the information of any certificate issued by X, so that the amount of information transmitted between them is much larger, right? So that is the source of this problem. Okay. The next focus could be web server. So we can measure the two most popular engines, Apache and Nginx, just to make sure if they correctly support OSSP stable, right? But the thing is, neither of them fully support it. For example, in case of Nginx, they do not prefetch OSSP response, which means they only try to fetch OSSP response from the CA's responder only if they got the client request, right? Of course, they cache this OSSP response to serve other clients faster, but they do not fetch this response in advance, which means always the first client will have to wait a significant of time for the web servers to fetch OSSP response from the CA's responders. And the browsers, we tested all the browsers, right? And the thing is, clients are largely not yet ready for OSSP most stable because, for example, the Firefox at the time was the only browser that understand OSSP most stable protocol, and the other browser, they didn't even try to parse, didn't understand what this OSSP most stable OID meant, right? So which means if the certificate has the OSSP most stable extension enabled, but if the OSSP stable response is not coming, but still they just accepted a certificate. They just successfully completed TLS and shake, right? So at the time, clients are largely not yet ready for OSSP most stable. Yeah. So the conclusion is OSSP most stable can operate only if all parties, involved parties, perform PKIs correctly. But the thing is, OSSP servers were not fully reliable, web server software were not fully supported, and browser as well. But the bright side was only a few players need to take an action to make it possible, because each web single administrators, they do not typically configure manage their web server software by themselves. They do not invent the whole wheel by themselves. So if the web server software is correctly configured, then it's good. Okay. So each individual of the web server administrator, they don't need to take a huge action. So the conclusion was, even though they are not, each party does not support it fully, but still, much wider deployment of OSSP most stable is a kind of realistic goal and achievable goal. All right. So in this class, we learn revocation protocols and how we can measure OSSP most stable protocols, evaluate them correctly using a active measurement technique. So in the next class, because we learn how the revocation protocols, in the next class, we're going to learn if this HTTPS PKI ecosystem is fully implemented and work as originally intended. Okay, So maybe because of the usability issue, maybe because of economical issues, sometimes the security protocols are not fully used as intended. So we're going to show you, I'm going to show you one quick example how HTTPS and the TLS PKI can be kind of degraded when economic concerns are kind of involved. All right. All right. All right. This is it. And thanks for listening to the lecture. And again, if you have any questions, please feel free to send an email to tj@virginiatech.edu. All right. Thank you so much. And see you next class. Bye.